Alright, so this is our introduction to ratios and proportions. You should be familiar with both those words from probably 6th through 7th grade. We're going to be talking about a lot more of multi-step problems in this year, so you really have to read carefully, and we definitely have to be familiar with ratios and proportions and very comfortable with them before we dive into these trickier problems. So a ratio is a comparison between two numbers. And we can see that in three different ways. So in these three problems, we're really just writing the ratio of dogs to cats in all three different ways that we can see this. So there's 3 dogs, 2 cats. That's a ratio of 3 to 2. So we can see it in words. We can write a colon in between. That's our second one. It's saying the exact same thing. It's still 3 to 2. We're just writing that with a colon. And the last one, and probably the most common, the most useful, is going to be written as a fraction. So 3 over 2. It's all expressing the exact same information. It's 3 dogs to 2 cats. So now we're going to use this picture to answer these 3 questions. We want to know the ratio of seals to turtles. The order actually is important. Actually, just looking at number 2, it's just going to flip the order, the ratio of turtles to seals. So the ratio of seals to turtles, we're just going to count seals first. That's 3. Then there's 5 turtles. You can write this in any way you want. I'm going to write it as a fraction. 3 seals to 5 turtles. For the second one, we're just going to flip that around. We're talking about turtles first and then seals. So that's 5 over 3. And then the ratio of turtles to animals. Well, they're all animals, so we're going to count all the total animals. That's really just 5 plus 3, which is 8. There's 5 turtles. That number's going to come first. And there's 8 total animals. So the ratio of turtles to animals is 5 to 8. A proportion is really just using 2 equivalent or equal ratios. So we're using 2 equal ratios. And let's say I wanted to compare, let's use this from before. Let's say we're talking about 3 seals to 5 turtles. And then I say in a zoo, we have 500 turtles. So there's 500 turtles. We're trying to think about 2 equal ratios. Well, if there's 500 turtles and they're equal ratios, that means there's going to be 300 seals. You can see that the top number was multiplied times 100, and the bottom was also multiplied by 100. That's how you can tell that they're equal ratios. They're also equal fractions. You could also check it by just dividing. 3 divided by 5 is 0.6. 300 divided by 500 is also 0.6. It's really important that we understand that the top stuff is all talking about the same stuff. It's all talking about seals here. The bottom is all talking about turtles. So we're going to set up a word ratio to understand the comparison. In this case, the word ratio would be seals over turtles. So most of the time we won't know all 4 of these numbers. We're going to fill in 3 of the known values and an unknown variable. Then we're going to use the magic of cross multiplication to solve this. We're going to talk about how exactly that happens in a minute, but we're going to cross multiply to solve for the missing variable. We always want to reread the problem to make sure that it actually makes sense, make sure our answer is logical. For example, if on the top number, in this example, we thought there were 600 seals, that really wouldn't make any sense because there's more turtles than there are seals. The bottom number should be bigger. So you always want to reread the problem and make sure it actually makes sense. On these two examples, we're going to shade in the correct proportional setup for each of the word problems. We're not going to solve anything, we're just setting it up. The most important thing to do when you're reading one of these word problems is to think about what units we're comparing, the numbers that are described and what they're actually describing. So there's 3 pipes, and they take 60 minutes to water a football field. 3 pipes and 60 minutes. We're talking about pipes compared to minutes. That's our word ratio, pipes over minutes. And we know that 3 pipes take 60 minutes. How much time will it take? How many minutes will it take to water the field with 6 pipes? So we know 6 pipes. But we don't know the number of minutes. That's going to be our variable. That's where our x goes. Okay? Now you're looking at these options, and none of them actually look the same. The first one's closed. It has 3 over 60, but then it has x over 6. That other side is flipped around. And that's a really important point about proportions. We don't need to think about it as pipes over minutes. It could also be minutes over pipes. It's the exact same comparison. So I'm going to flip the entire thing, and I'm going to look at this as 60 minutes over 3 pipes. And that's the same as some number of minutes compared to 6 pipes. The question is really what tells us our word ratio. I wrote it a little bit early in this one. You'll see that in the next one. We really want to wait for the question to start writing our word ratio. So we can see that one lines up with our second option. So I'm going to shade that one. We have minutes over pipes. That is the correct solution. The second one says, on average, Crystal makes 5 free throw attempts and misses 3 attempts. How many successful free throws would she be expected to make out of a total of 200 free throws? The question is going to tell us our word ratio. Really be careful about this. You're not using 5 and 3 in the proportion at all. The question is talking about the number of successful free throws that she would make out of a total of 200 free throw attempts. It's not talking about success versus misses, like the first sentence is. It's saying successes versus the number that she takes. So that's our word ratio. Success over, I'm going to call that total. You could also call it attempts. So she's making 5 free throws and missing 3. That means she has 5 successful free throw attempts and 8 total. She's making 5, missing 3. That's a total of 8 shots. We want to know how many she's going to make, how many successful free throws she's going to have out of 200. That's that option just below the first one. So that's the bottom left option. 5 out of 8 is the same thing as some number out of 200. All right, now we get into actually solving them. So the cross multiplication part of this. When we cross multiply, you can actually draw an x over the equal sign. You're cross multiplying. When we cross the equal sign, you're multiplying those two. So we're multiplying x times 10. That's 10x. And we're going to rewrite the equal sign in between and then multiply the other two and put that on the other side. 4 times 5 is 20. You should know how to solve a one-step equation. We're thinking about the opposite of multiplying by 10. We're really trying to get x by itself. So you want x equals something. So if you get rid of this 10, we're going to use division to undo that multiplication. Those cancel out. That gives us the x by itself. And 20 divided by 10 is just 2. Same kind of steps on the next one. We're cross multiplying. I always write my variable on the left side, so I'm multiplying 10 times x again. And that equals 2.4 times 20 is 4.8. Same exact last step. You always just divide by that extra number. Whatever's being multiplied times the x, you're going to divide by that. Sorry, I kind of jumped to the answer there. It's really 48. I was thinking one step ahead. We're going to divide that by 10. So x equals 4.8. 48 divided by 10, that gives us that 4.8. Same kind of thing on the next one. 8 times x, we're going across that equal sign. 8 times x is 8x. 10 times 4 is 40. And then we divide by 8 on both sides. X equals 5. You could always plug this in to make sure it makes sense. 10 divided by 5 and 8 divided by 4 should be the same thing. 10 divided by 5 is 2. 8 divided by 4 is 2. It's really just showing two division problems on either side, so you can always check it. All right, now we get into some serious word problems. So on these first two, we're just going to be given three numbers, and we're going to find the fourth. So it's exactly like we just did. We're going to cross multiply to solve for that last number, and we're going to be given all the numbers that we need. Then you can see the next example, we're actually going to need to really think about one step ahead what three numbers we need to actually solve for that fourth one. All right, so questions 4 and 5, just trying to set up a proportion first. The question 4 is saying, during a rain delay, tarps need to be rolled over the baseball field. One tarp can cover 2,700 feet squared. How many tarps will it take to cover the 8,100 feet squared infield? So we're comparing the number of tarps and the area, the feet squared that it takes. Those units really give it away. One tarp and 2,700 feet squared. We're talking about tarps to areas. One tarp covers 2,700 feet. How many tarps? We don't know that yet. How many tarps? That's our X. That is the question. How many tarps will it take to cover this 8,100 feet? Now we cross multiply. 2,700 times X is 2,700 X. And that equals 8,100 times 1, which is just 8,100. And we divide by 2,700. And X equals 3. You always want to think about, does that answer really make sense? Does 3 tarps make sense? That's what we found on the number on the top. That's talking about tarps. This is talking about 3 tarps. That does make sense. We're tripling the area, so it should take 3 times as many tarps. It's more area to cover. It should take more tarps. All right, number 5 is talking about a cookie recipe calling for 1.5 cups of chocolate chips to make 24 cookies. How many cups of chocolate chips would it take to make 110 cookies? So we're talking about chocolate chips and cookies. How many chocolate chips will it take to make 110 cookies? Alright, so 1.5 is really 1, and then that half part as a decimal is 0.5, so I'm going to change that to 1.5. I don't really want to deal with a fraction inside of a fraction. So 1.5 cups of chocolate chips compared to 24 cookies. That's some number of chocolate chips compared to 110 cookies. Cross multiply 24 times x is 24x. 1.5 times 110 is 165. Again, our last step is always just dividing, so we're going to divide 165 by 24. So x is 6.875. Always think about what that really means. It's almost 7 cups of chocolate chips. I'm just going to say it's cups. And that does make sense. We're making a lot more cookies. It's going to take a lot more chocolate chips. All right. 6 is saying that the Atlanta Falcons won 5 games and lost 1 game. If they keep the same pace, how many games will they win if they play 36 games? So we're talking about how many games they're going to win. We don't know the number of games that they're going to win. That has to be a part of our proportion. That's what we're looking for, how many games they're going to win. And in the question, they're talking about how many games they play. It's not talking about their losses, it's talking about how many games they play. It's 36 games played. I'm just going to call that games, just the total games. If they win 5 games and they lose 1, they're playing a total of 6 games. So our first ratio is 5/6. We don't know how many they're going to win, but we know that they're playing a total of 36 games. So again, we cross multiply and then solve for x. 6 times x is 6x. 5 times 36 is 180. And we divide by 6, and x is 30. Which makes sense. They should win most of their games. 30 wins out of 36 games. That makes sense. You could ask how many games they lost. You could actually set up the exact same proportion there if you wanted to find the number of losses. You would just have to subtract that from 36, so they actually lost 6 games. The answer to that question is 30 wins, but you could also work backwards and figure out that they lost 6. 7's saying that there are 12 boys and 14 girls in your English class. If the same ratio exists in the whole school, about how many girls are there out of the 1,110 students at Liberty? The question tells us our proportion. How many girls are there out of all of the students in Liberty? That's boys and girls together. Okay, so we're talking about girls compared to all of our students. This is a misleading question because the first ratio that you see is 12 to 14, and you're thinking that's got to be a part of my proportion, but it's boys versus girls. It's not talking about total students. The total number of students is 26. It's 12 plus 14. So our total students is 26, and 14 of those are girls. We don't know how many out of the 1,110 students are girls. So you cross multiply, and we get 26x equals 15,540. Then divide by 26, and we get that x is 597.69. And it's saying about how many, that's telling us to round that. We're talking about people, so we're not going to have 0.69 of a person. You're not going to have half of a person. So we're going to round that to the nearest whole number. So it's about 598 girls. Another way we can use our proportions is using a percent in the proportion. A percent is actually a ratio in itself. It also tells us the word ratio, pretty much. It's the percent out of the total. Anytime you're talking about a percent in a proportion, it's always talking about the percent out of the total. And the convenient thing is we actually already have 2 of the numbers when they give us that. Like in this problem, I didn't even read the problem. All I see is 80%. I know I have 2 numbers already. I'm going to put 80 over 100 as my first part of the proportion. I'm going to read it first. Our last test had 30 questions. If you got 80% of the questions correct, how many questions did you get correct? 80% is describing the number correct. A percent is always out of 100, so you can start off with that 80 out of 100. And then we have to think about what that 30 is talking about. It's talking about the total number of questions. It's not talking about the number correct. Actually, the question is looking for the number correct. So our x is going to go on top. We don't know the number correct, but we know we had 30 total questions. So we cross multiply, you get 100x. And 30 times 80 is 2,400. We divide 2,400 by 100. And we get that x is 24. Which makes sense. We're getting most of the questions correct. 24 out of 30 is a pretty good percentage. You could also work backwards to figure out how many you got incorrect. That's just 6. You're really just doing 30 minus the 24. The next one says the library has a total of 6,075 books. If 2,225 books are checked out, what percent of the books are not checked out? Okay, it's asking what percent. That still tells us part of the proportion. We're looking for the percent not checked out. And it's always out of the total. The percent is always out of the total. We're looking for what percent, so we don't know the percent yet. That's going to be our x. And it's out of 100. We don't know the percent, but we know it's going to be over 100. On the other side, we have to think about how many books are not checked out. Well, if there's 6,075 total books, and some of them are checked out, we're going to subtract those two. 6,075 minus 2,225 books that are actually checked out. That leaves us with 3,850 books that are not checked out. Still out of the total, which is the 6,075. So we cross multiply, and then we're going to divide by the 6,075. That gives us about 63.37%. Which again makes sense. There's most of them that are checked out, so it should be more than 50%. I usually just round to the hundreds place. That's that 7, so 63.37. You don't want to round that to the nearest whole number. Don't round that to just 63. Keep at least one decimal place. But if you wanted to write 63.4, that would also be okay.